This is Physical Science 20, Introduction and Review. This is Lesson 2, Multiplication and Division with Significant Figures, to go along with the IR3 assignment. The rule when multiplying and dividing with significant figures is the answer has the same number of significant figures as the number with the least significant figures being multiplied or divided. Example 1. 0.00210 has 3 significant figures. 4,132 has 4 significant figures. According to our rules, our answer has to have the same number of significant figures as the number with the least number of significant figures being multiplied or divided. And since 3 is smaller than 4, that means my answer has to have 3 significant figures. So the 8.67 is going to be significant. The 7.2 is going to have to go. So I will round off the 7.2, and 8.67 then becomes 8.68. Now for my units. I got meters per second squared multiplied by seconds. I like to write it as 2 fractions. Once I've written it as 2 fractions, I will then factor out whatever is common in the numerator and the denominator between the 2 fractions. So I have an S on the top and an S on the bottom that can factor out. Now that I have nothing else that will factor out, I see that I have an M on the top and an S on the bottom. So my final unit will be meters per second. So 8.68 meters per second. Example 2, 2,345 has 4 significant figures and 0.19 has 2 significant figures. So that means my answer is allowed to have 2 significant figures. So the 1 and the 2 is what I'm going to keep. 342.10526 is what I will have to round off. So 12,342 will become 12,000. Now for my unit. I have meters over seconds, and that's being divided by seconds, which I write as seconds over 1. Now remember back to grade 8. When we had 2 fractions and a divide sign, we changed the division sign into multiplication by flipping the second fraction. So meters per second stays as meters per second, and then it's multiplied by 1 over seconds. Nothing factors out, so I wind up with M on the top and S squared on the bottom. So my answer is 12,000 meters per second squared. Example 3. 45 has 2 significant figures. 134 has 3 significant figures. So that means my answer will have 2 significant figures. So I'll keep the 6 and the 0, and 30 will have to round off. But when I round it off, I get 6,000. I need 2 significant figures, so this can't be right because there's only 1 significant figure, and that's not enough. So I'll put in a decimal. But that's still not right. I need 2 significant figures, and this has 4 significant figures, which are then too many. So how do I show 2 significant figures? This is an example where the number must be put into scientific notation because it is not possible to identify which zeros are significant and which are not if the number is out of scientific notation. So if I write 6.0 times 10 to the 3, that is 6,000. And that does have 2 significant figures. Now for my unit. I've got kilograms, so that'd be kilograms over 1, multiplied by meters over seconds. Nothing factors out, so in the numerator, I have kilograms multiplied by meters, and on the bottom, I have seconds. So my unit is kilogram meters per second, which seems odd, but that is the unit for something we call momentum. Example 4, 0.00039 has 2 significant figures. 48000 has 2 significant figures. That means my answer has to have 2 significant figures. But all those zeros in front cannot be significant, and this is all my calculator is saying. So if I need 2 significant figures, what is behind the 8? Some people like to assume it's a 0, but if I have a 0 at the end of the number and there's a decimal, that means it's significant, which means it was measured. And I just guessed it was a 0 because I really don't know what it is. So that can't be right. So what am I going to do? So we can't assume that there is a 0 after the 8. So how do we determine what is after the 8? We must set our calculator to display answers in scientific notation. When I do that, I get 8.125 times 10 to the negative 9. I only want two significant figures, so I'll keep the 8.1 and the 2.5 will get rounded off, so I get 8.1 times 10 to the negative 9. Now for my units. At kilograms, meters over seconds, and that's being divided by seconds. So I'll write that as kilogram meters over seconds multiplied by 1 over seconds. Nothing factors out. I have kilogram meters on top, seconds squared on the bottom, so my unit is kilogram meters per second squared. Again, that looks like an odd unit to us, but as you move into physics, and in grade 10 you might have seen this, that is mass times acceleration, usually written as just newtons, but that is the unit for force. And that's the end of the lesson. You're good to work on the IR3 assignment.